Welcome to Study Loop.
So we have in this question an ice which has a mass of 0.35 kg. Now the sophomore adds in some amount of heat into that, but we don't know how much heat it adds. The ice is at 0 degree. So the question asks us, what is the change in entropy of the water? Now to determine the change in entropy of the water, it is del S, we need to determine how much heat was supplied to the ice and at what temperature the system was. So to find out this Q, what we do is the heat required to melt that ice from 0 degree, ice at 0 degree to water at 0 degree is given by mass of ice into latent heat of fusion of ice. Let me denote this by LF. Now we know that the latent heat of fusion, the value for this is in SI unit 3.34 into 10 to the power 5 joule per kg, right? So let me use these two values of M and LF in this equation, then you can get the value for Q to be 1.17 into 10 to the power 5 joules. So this much amount of heat was given to the ice. So change in entropy is given by, if you substitute the value of Q and T, you get 1.17 into 10 to the power 5 divided by the value of T is how much? 0 degree, but you have to change that into Kelvin, remember that, okay? So it is 273 Kelvin. Now as you divide this, you're gonna get 429 joule per Kelvin. Okay, so we are done with question number A. Now the question number B says that, so this is for A. Question number B says that the source of heat is a very massive body at 25 degrees Celsius. So since it is very massive, its temperature doesn't change much while giving heat to ice, so its temperature remains almost equal to 25 degrees Celsius. So what is the change in entropy of this body? Now for that body, the body lost some heat, so entropy is equal change in entropy equal to how much heat did it lose. Now the Q is, now it is in minus because it lost that heat, so heat lost is equal to 1.17 into 10 to the power 5 in negative divided by the temperature of that body remains almost 25 degrees, so we're at 273 plus 25. Now this gives us the change in entropy to be 393 joule per Kelvin. Now what is the total entropy change of the water and heat source? So total del ST is equal to 429 minus 393, which is equal to 36 joule per Kelvin. So this is the total change in entropy. Note that the entropy is increased here since this is a irreversible process. Okay, so this ends the solution for this question. Thank you.